Hello, in this demo video, we'll see how to onboard a new VM to AccuKnox SaaS platform, and also we will enforce some policy to the VM as a host policy and the containers that are running inside the VM. Right. So to onboard a new VM, we need to navigate to the settings, click on Manage Clusters, then click on Onboard Now, and then give it a name, any name. Let's say VM demo. Then click on Save and Next. Here, clicking on VM, you can see the virtual machine onboarding steps. So there are three steps to onboard VM on the SaaS platform. But before we get to the actual onboarding steps, let me quickly discuss the prerequisites that are required. Right. So as we are treating the VM as a control plane node and worker node, right, and installing our agents inside that. So let me quickly explain the control plane node first. Control plane VM, right? So in terms of Kubernetes, we used to say control plane node where we connect all the worker node. Now here we are treating one VM as a control plane VM where we will be installing all the AccuKnox agents as a Docker containers, right? So all the AccuKnox agents will be running there as a Docker container. And then we have the worker VM and we will connect the worker VM to the control plane VM using the control VM address, right? So we require these agents to run as a Docker container, right? So the prerequisite we have here is Docker should be installed there, Docker Compose should be installed there in each of the VMs, right? Then there should be BPF LSM support. Other than that, there are some resource requirement. So for control plane VM, we require 2 CPU, 4 gigs of memory, and 64 disk space, right? For worker VM, there is a requirement of 2 CPU and 2 gigs of memory, right? So let's get to the platform and see how the onboarding will work, right? So here we have the first step. The first step is basically to install AccuKnox CLI. It will first curl the Knox-Cuttle binary, then extract it using tar, then making it executable, and then moving that particular binary to user local pin path, right? So let's copy this and paste it here. So we need to install Knox-Cuttle in the control plane as well as the worker VM. So I have pasted here. This one is my control plane VM and this one is my worker VM, right? So while it get installed, let me quickly discuss the second step. So the second step is after the Knox-Cuttle binary gets installed, we need the Knox-Cuttle command, right? So in the second step, we are making use of the Knox-Cuttle onboard VM CP node command, right? To onboard the control plane VM, right? So this command will first install AccuKnox agents like Vader service that collects the KubeArmor feeds, then share informer agents that authenticates with the VM to collect information related to the VM. Then PEA, the policy enforcement agent that we have, it again authenticates with the VM to enforce levels to the policy, right? So this command will install all the agents, all the required agents in the VM. Let me copy this command and let's see if we have Knox-Cuttle installed. So it is here. In this case, it is also here. So we need to run this command, the second step command, in the control plane VM only, right? So let me quickly run it. It will first pull all the container images that is required and then it will run all the container images. So we can see 3 out of 10 is running, right? Then after the second step, we have this third step. Third step to basically connect the worker VM with the control plane VM. So for that, we have Knox-Cuttle onboard VM node command with the control plane VM address, right? Now let's get to the plat CLI, and here we can see our control plane VM is successfully onboarded. Now we have this command, the same command which we can see this third step. Let's copy this command. Let's paste it here in the worker VM. Also we require the IP address of the control plane VM, right? So let me quickly copy the IP address from here. Here we have the address. Now let's paste the address here. It is CP node address, right? Now it is pulling KubeArmor images, and then it will be done, right? So let's wait for a few seconds. Right. Now we got a message. We can see VM successfully joined with control plane. Right. So we have successfully connected our worker VM with the control plane VM. Right. Now let's quickly verify it. Click on next. It will be redirected to cloud workload where we can see all our workloads. Right. So if I click here, we have the name VM demo here. Clicking on it, we can see all the container images that are running inside our VM. Now let's quickly verify if we have successfully connected the worker VM as well. So click on view nodes. Right. So here we can see we have two nodes. This one is our worker node and this one is our control plane node. Basically the control plane VM and worker VM. Now we will enforce a policy to it. So to enforce a policy, navigate to the runtime protection, click on policies, then click on create policy. I already have a policy, so just select the VM option from here to enforce a host policy. Right now I will upload a policy here. This policy is basically to block the execution of apt and apt-get command inside the VM. Right, let me select the cluster name from here. It's demo, VM demo. Right, now click on save to workspace, and here we have the KubeArmor host policy. Now click on the three dots and click on apply policy. So after clicking, we need to confirm it once. Right. So now we have the policy in active state. So we can see the status of the policy. Right. Now let's get to the VM. Right. Now let's try to use app command. It got a permission denied. App-get, it also got a permission denied. Let's see if we have any alerts here. Right, so we can see we have alerts, right? So this alert is for app command that we execute. You can see the process name is apt here, got a permission denied, right? The enforcer is BPF-LSMs, the host name here. Also we have the cluster name VM demo, right? The action is block, and there is some message apt was attempted to be executed, right? So other than the app, we also used apt-get command, right? So for that we have the alert logs here, right? Process name is apt-get. Now let's deactivate the policy and try to execute the same command without the policy being active, right? So the policy is an inactive state. Now let's go to the CLI again, try to execute apt-get. It is working. Apt, it is also working. So after deactivating the policy, these commands are working fine, right? So we can make use of this policy to restrict any kind of access, whether it is related to process, files, or networks, right? So now we will enforce a policy to a container, right? So to test it out, let me quickly spin off a container here, and I will make use of Ubuntu image, right? So here I have the command. Let me quickly run a container. So this command will run a Ubuntu container with the latest image, and also we will get a sale, right? So right now we are inside the container. Let's see, we are root, right? So we are already inside the container. Let's see if we can see the container here under cloud workloads or not, right? So click on cloud workloads. Let's go to the clusters, click on VM demo. We have the Ubuntu container here, right? We can see the Ubuntu container running inside the container namespace. Now we will enforce a policy to this Ubuntu container. So to enforce a policy, we can directly add the policy from here, or we can go to the runtime protection policy section. Now create a policy. I already have a policy for file integrity monitoring here, right? So I will just edit this policy. What this policy will do, it ensures the integrity inside this mount point, the user bin, user SBOM, SBIN, user leave, and food should not be tempered, right? So whatever files and sensitive assets are there inside this mount point, the content of those files should not be changed and should not be tempered. Even if we try to delete that file, we won't be able to delete it, right? And even we won't be able to create anything inside this kind of binary, as we are only allowing the read-only access permission there. Other than the read-only permission, there is no write permission, right? So let me quickly write a VM. What's our VM name? It's VM demo. Then the namespace is container namespace. App level is okay. That is Ubuntu. Tag we don't require. So yep, let's update the policy. Right. So we have the policy here. Now we'll just apply the policy. Confirm, and the policy is in active state, right? So let's get to the container, navigate to user SV. Now let's see what all files are here, right? So I'll just try to create any file here, right? It got a permission denied, right? So as we allow only read-only access permission to this mount point, there should not be any execution of process inside there, right? We cannot create anything here, we cannot delete anything from here, and even we cannot change the content of the pre-existing files that are already here, right? So let me try to remove anything. So user add, it is also got a permission denied. Let's see if we have alerts here. Right, so here we have the alert. So if you see the alert, it is for the test command to create the test file that we just tried to create, right? It got a permission denied. Here we have the enforcer is BPF LSMs, the cluster name is VM demo, and the container image and container name, that is Ubuntu, right? Container namespace with a message detected and prevented compromise to file integrity, right? So we also tried to delete anything, right? So let's see, we have logs. Yep. So we have these logs for deleting the user add binary, right? Using rm command. So as soon as we do the violation, we get the alert, right? Now I'll just remove the policy. I'll deactivate this policy, and then I will try to create anything inside that mount point again, right? So now we have deactivated the policy. To deactivate this policy, we just require it to select it and click on make inactive, right? It will get inactive. Now let's go to the CLI again, and let's try to create the test file again. Yes, so let's see if we have the test file, right? So there is a test file, right? We just use the test command to create the test file, and we have the test file. So after removing the policy or before applying the policy, we can create anything here, we can delete anything from here, right? But after enforcing the policy, we are ensuring the integrity of this particular mount point and the files that are inside it, right? So that's about the video. Thank you so much.